in the last module also we have talked about the hydrostatic stress. If you remember hydrostatic stress or hydrostatic pressure, then also we talked about the stress regulator there. Okay. So based on this, we have to today study, little bit almost we have covered some of the parts. So again, I will just recap that one. One is the maximum shear stress or the Tresca criteria. And second one, we will talk about the Hormesis or the distortion energy criteria. Maybe 1-2 slides. Then based on this, we will make one numerical. So this slide also we have covered. When we are talking about the shear stress, also you have to understand what is the maximum shear stress. Okay. So if you look the schematic diagram, I think this kind of schematic diagram already I have shown in the previous module. So even the first picture you can see here. So you do not have any shear stress there. Okay, so that's why I put here on the faces of the principal element. So whatever the principal stresses you have, sigma 1, sigma 2, sigma 3, these are known as the principal stresses. But whereas you do not have any shear stress there. But the moment you are making it inclined, okay, for example, if you see the schematic diagram, like the second part, or third part, and fourth part, so you have the face angle there. So how much angle I mentioned here? So this is almost 45-degree angle. Okay, so the moment you have the 45-degree angle, so you will find both normal stress at the same time. Also, you will find shear stress. Okay. So how we will find this one? If you remember, the Mohr circle actually you have studied maybe somewhere. So I didn't put in detail. So the Mohr circle is useful in visualizing the relationship between the normal stress and the shear stress. So if in your sample or in your crystal, if you have the normal stress is available or your shear stress is existing, then with the help of the Mohr circle, you have to define or you have to find out what is the shear stress. So based on this, you have to find out the shear stress. For example, the tau 1 equal to the shear stress sigma 1 minus sigma 2 divided by 2. Similarly, if you want to find out the shear stress 2 sigma 2, sorry, tau 2, you have to sigma 2 minus sigma 3 by 2. And also the tau 3 equal to sigma 3 minus sigma 1 by 2. You have to find out length. Okay. So again, how you have to find out this thing. So with relate to, again, you have to, because the flow stress, what we have discussed about the sigma f, then you have to relate with the flow stress. So it might be anticipated that the yielding, whatever the yield stress we are talking about, the yielding would be dependent on the shear stress in an element and the current value of the flow stress. Okay. So if you compare with all these shear stresses here, the tau 1, tau 2 and tau 3, whatever we have found out here, then if you want to convert or if you have to relate to the flow stress, so you can make this as the sigma f equal to function of tau 1, tau 2 and tau 3, right? Is it clear? Okay.
Yes, sir.
Okay.
Yeah.
So then, yeah. So then if you want to go, for example, the hydrostatic stress, again, I just put, a few sentences here, but I copied from my old slides in the module 2, what we have talked about. So if you have the sample here, so when hydrostatic stress, normally we are considering as the average of the principal stresses. Okay, so for example, sigma h equal to whatever you have the principal stresses, 3 principal stresses you have. So sigma 1 plus sigma 2 plus sigma 3 by 3. So these are and whatever the remaining part, so the component of the stress, the components of stress remaining after subtracting the hydrostatic stress have a special significance, and that is known as the deviatory or the reduced stress. That one you know. Okay, already I put. But only this equation I have mentioned here. Okay, so sigma 1 dash equal to sigma 1 minus sigma h. So this one, the sigma 1 dash is known as the deviatory stress. Similarly, instead of sigma 1 dash, also you have to make it sigma 2 dash and sigma 3 dash. Okay. And also, if you want to make, for example, we have alpha here, so alpha is known as the stress ratio. Okay, so we are not going to detail how to derive the stress ratio. If you want, you can just follow the detail book, everything is there. Okay, so that I just put if instead of this deviated stress, if you want to relate with the stress ratio, then it will form as sigma 1 dash equal to 2 minus alpha by 3 into sigma 1. But if you want to calculate this one, how to calculate, just I put here, instead of, the whatever the principal stresses we had, but now the principal stresses you have to change. So initially it was sigma 1, and the sigma 2 you have to consider as alpha into sigma 1, and sigma 3 equal to 0. And if you will take these three terms, if you will put here in this equation, in the first equation, sigma 1 dash equal to sigma 1 minus sigma h. So if you will put instead of sigma and a sigma 2 and a sigma 3, then you will find this equation. Sigma 1 dash equal to 2 minus alpha by 3 sigma 1. And where actually how this alpha is coming, just maybe I will just a little bit I will tell in the next slide how the alpha is coming. Okay.
Yes.
Yeah. So the next slide, it is so that the maximum shear stress or the Tresca criteria. Okay, so how to, because almost we have covered about the hydrostatic stress and the derivative stress. But now if you want to calculate the maximum stress or the Tresca criteria, okay, how much it will be. So if you see the schematic diagram here, the yield locus for the plane stress for the Tresca criteria. So if you see here, what I told in the beginning, if you have your plane is inclined, not in the simple way. If it is inclined to 45 degree or any angle, so you have to find out this alpha is here because this is inclined. So that's why this alpha is multiplied to that sigma. Okay, because this one you have to consider as alpha 1, this one, but whereas if you want to this one consider as sigma 2, but this sigma 2, because this is inclined, so you have to multiply alpha into sigma 2, whereas we do not have sigma 3 here, so this sigma 3 term will be 0. Okay, so here also in the tensile stress where sigma 2 equal to sigma 3 equal to 0, here it is considering, so the greatest maximum shear stress. So if you want to consider the maximum shear stress or the greatest one, if we compare from the all, so you have to assume that sigma 2 equal to sigma 3 equal to 0, and this one is the value is the tau critical value equal to the sigma f, that means the flow stress whatever we have divided by 2, and whatever we have considered before sigma 1 minus sigma 2 by 2 equal to the delta the sigma f by 2. So this equation is known as the Tresca criteria equation. Or in other way, if you want to quantify or if you want to take the value of or the magnitude of that sigma f, then the sigma f you have to consider as the sigma max minus sigma min. What is the maximum value you have, and you have to reduce the minimum value, then you have to find out the stress value or the flow stress. Okay. Then the next one, we have the von Mises or the distortion energy criteria. So here also, if you want to consider the yield locus for the plane stress for the von Mises yield criteria, that one we have considered in a rectangle, but here you are considered in a ellipse. Okay. So what you have to find out? So the other widely used criteria is that yielding will occur when the root mean square value of the maximum shear stress. You can understand here, when the root mean square value of the maximum shear stress reaches a critical value, and the criteria is known as von Mises yield theory. So that means if you have the three, this stress, shear stress are there, tau 1 square plus tau 2 square plus tau 3 square divided by 3, and you have to make it root over equal to, you will find out 2 into whatever the flow stress you have divided by 2 square by 3. This is the basic, your definition. This one is the definition. Then from here also you have to convert this one, the root over 2 into tau square plus tau 2 square plus tau 3 square equal to sigma f. How will you convert? Whatever the value you have, for example, the sigma 1 minus sigma 2 by 2, or maybe the tau 1 minus tau 2 by 2. If that value you will put here, so you will find this is your homework. You can do at home. Okay, so I have already done this one. So maybe you can try this one. If not, then also I will share my whatever I put in my rough paper. I will just share. Okay, and substituting the principal stresses for the maximum shear stresses, the yielding condition can be expressed from here actually. If you have the tau 1, if you remember the tau 1 equation we had and tau 2 equation and tau 3 equation, so that equation, with respect to the stress, if you want to put this one, then you will find root over half into sigma square minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma whole square equal to sigma f. But now here, if you want to solve from this equation to this equation, now you have to open this bracket. For example, this is a minus b double square, and also this a minus b double square. So that means you have to write a square plus b square minus 2ab. And if you want to put like this equation, then you will find this equation. Okay, sigma 1 dash equal to 2 sigma 1 minus sigma 2 by minus sigma 2 divided by 3 from this equation. So I'll just put directly here, so you can just try it home. Okay, this is possible. This is working because I have done it. Okay, and from this equation, you have to find out the 3 by 2. If you solve it, because only this is direct equation I have just mentioned. If you solve it, you can find out 3 by 2 into sigma dash square plus sigma 2 dash square plus sigma 3 dash square equal to sigma f. Okay, so this is the basic equation of the von Mises criteria. Okay, is it clear?
Yes, sir.
Maybe you have to try because this is a derivation little bit, so you have to little try. For example, if I mention, this the first equation is the basic definition. You do not need to do anything. Okay, and this equation, this big equation, half into sigma 1 minus sigma 2 square. So what you will do instead of this tau 1, so we have to put this equation. You have to put this equation. Okay, sigma 1 minus sigma 2 by 2, then tau 1, tau 2 equal to sigma 2 minus sigma 3 by 2, tau 3 equal to sigma 3 minus sigma 1. If you will put this equation, then you will find that equation, that will final. Okay. Then also when you are finding the sigma 1, sigma 2, then whatever we have mentioned the deviatoric stress, if you will put there, then you will find sigma 1 dash equal to half. Okay, maybe 4 or 5 steps you need extra. Okay. So based on this, now two equations we have found. One is the von Mises criteria, and another one is we have this Tresca criteria. Okay. So based on this, we have two numerical actually. So maybe you can do. We have enough time. We will start the quiz around 9:25. Okay. So you can make this example. A steel pipe, 320 megapascal, has a diameter of 10 centimeter and a thickness of 1 millimeter. What pressure is required to produce yielding in a wall of the pipe? Apply both von Mises and Tresca criteria. And you have the principal stresses are given. Okay, so one is sigma 1 is given P R divided by 2T. Sigma 2 is given P R by T, and sigma 3 is given 0. So can you calculate both? You have to apply von Mises criteria equation, then also Tresca criteria equation. Just try, maybe 2 minutes you can take, then I will show the answer. So you can just write out because three principal stresses are given: sigma 1, sigma 2, sigma 3. Okay. So you have to find out what pressure is required. So that means you have to find out the P. So what will be the Tresca criteria? The formula? Anyone? No one.
Yes, sir. 1 second. Sir, it would be sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus 1 whole square is equal to 2 into S by T by N whole square.
But this is von Mises criteria.
Yes, sir.
Okay, so how much it is coming?
Yes, we're calculating.
Yeah. Others are also requesting, please calculate. So instead of sigma 1, you have to mention PR by 2T. Instead of sigma 2, you have to write PR by T, and instead of sigma 3, it will be 0. So from that, you have to find out P, because P is the pressure. Okay. And you have also diameter is given. So diameter is 10 centimeter and thickness equal to 1 mm. Thickness is T. Okay. And the diameter is D.
So that Tresca criteria is shear stress, right?
Which one?
Tresca.
This is, yeah, shear stress. But why you are going for shear stress?
Sir, they have mentioned to do it with both von Mises and Tresca.
Yeah, yeah. So I think tau is not necessary. So how much is von Mises? Because T is given thickness 1 mm. R is given how much is R? 5 centimeter. Okay, sigma is given this like the sigma y or maybe sigma f 320. You are getting my point? All are silent. Amal,
Yes, sir. Yes, sir.
doing or studying for quiz?
No, sir.
I think next time we should do quiz first, then we should study, right? Charles?
Right.
Okay, maybe I will show. Maybe next time we will do quiz first, then we should go for the study. Okay, you can just see. Maybe Sai you are doing, I think. Yeah. Okay, just you can cross check. So your sigma 1 is given PR by 2t, sigma 2 is given PR by t, sigma 3 is given 0. Okay, so one misses criteria you have 1 by 2 sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 square plus sigma 3 minus sigma 1 square and then root of 2 equal to sigma 1. Okay, so if you want to convert the sigma y is given 320 megapascal. This is okay. And if you have, it is asking that what pressure is required. So that means you have to find out P, whatever the P you have inside. So that P you have to find out. And R is given because this diameter is given 10 cm. So radius is 5 centimeter. Thickness is T. So T is given 1 mm. Okay, so you have to convert to either cm or maybe mm. So better to convert to cm. So if you'll put all the value here, because this is a minus b whole square, this is also a minus b whole square, this is also a minus b whole square. So if you'll convert and if you'll put all the values here, you will find 7.390 megapascal. Okay, because everything is there. Now, R is there, sigma y is there, T is there. So only you have to find out P. Right?
Yes, sir.
So you will get 7.39. Maybe you can find maybe other value. And if you want to go for the Tresca criteria, the Tresca criteria will be sigma max minus sigma min by 2 equal to sigma f by 2. Okay, so from here you have to sigma max is given, for example, 1 because you have now two values are there. Okay, one is sigma 1, sigma 2. Okay, so you have to make 1 sigma 1 minus sigma 2 divided by 2 equal to sigma f by 2. So you have to find out sigma is how much. So sigma f will be 6.4 megapascal. Okay.
Yes, sir.
You can do, you will find out this value 6.4. Okay, so one more question we will do, then we can stop. Is it clear for all?
Yes, sir.
Okay. Harish? Okay, maybe nobody will respond to it. Okay, fine. So
Sir?
the next, yeah.
Sir, sigma max is sigma 1 and sigma minimum is sigma 2, sir.
Yeah. Like if, for example, if you can take sigma 1 minus sigma 2 by 2 or maybe sigma 2 minus sigma 1 by 2. Okay. Which is maximum you can take. For example, if you put the value, so which is maximum you can take.
Sigma 2 will be maximum, sir.
Yeah, so then sigma 2 minus sigma 1 by 2, it's not an issue. Because if you make sigma 1 minus sigma 2, I think it will be minus. Okay, because it is smaller. So the sigma 2 is
Sir,
the highest one.
We can take 0 as sigma min, sir.
No, because this value is 0, so that means this not exist there. Okay, so you have to take these two.
Oh, okay.
Okay, because this is 0, then this is not exist. So only two are existing. So which is maximum you can take first, which is minimum you can take last. Okay, so I think sigma 2 minus sigma 1 divided by 2 you have to take.
Okay.
And next question is this one. Stress analysis of a spacecraft structural member gives the state of stress shown below. If the part is made from 7075T6 aluminum alloy with sigma 0 equal to 500 megapascal, will it exhibit yielding? If not, what is the safety factor? Apply only one misses criteria. And this picture is given. Okay, so sigma S is given here 200 megapascal, sigma Y is 100 megapascal, and sigma Z equal to 50 megapascal. Okay, and the tau xy equal to 30 megapascal. So you have to now calculate whether it is yielding is existing or exhibit or not. If this is exhibit, this is fine. If not, then what will be the safety factor? So the same the von Mises criteria equation you have to write the root over half into sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 square plus sigma 3 minus sigma 1 square.
Sir, we'll just have to apply the von Mises criteria and find the yielding stress, isn't it, sir?
Yeah. But you have to check whether this is it is exhibit or not. If this is not exhibit, then you have to find the safety factor. This is just the whatever value you have given the total stress divided by what you are taking. So this is the safety factor.
Okay, sir.
So you can calculate how much is sigma 0. So please understand, your sigma z is opposite direction. Yeah.
Sir, 224. Sir. Sir.
Yeah.
Sir, 224.
224. Yeah, 224 megapascal. Yeah, fine.
Well,
And then
what-
if it's
There
an
is-
exhibit or not?
It is 224.0 for this decimal
Yeah,
places.
it's fine. And what will be the safety factor?
2.23.
2 point. Yeah, fine. So how much is sigma 1 minus sigma 2? And you have
Yes, sir.
how much sigma 1 minus sigma 2?
So maximum minus minimum.
So how much? 200 minus 100, right?
Yes, sir.
Then next one. Sigma 2 minus sigma 3, right? How much?
100 minus 50, sir.
Yeah, because opposite direction is there. Then third part.
Third is minus 50, then minus 200.
Okay. Then other part you have
So tau.
how much tau?
30, sir.
30.
Yes, sir.
So how much it is coming now? 1 by root 2 into so it is 224, right? Maybe I have to cross check. Maybe I'm
Yes, sir.
thinking-
It's 220.
Yes, sir. Yeah, then this is fine. Okay. Then the safety factor is 2.2. Okay.
Yes, sir.
Yes, sir.
Okay, fine. Okay, so just you can try again both the numerical, you can try at home. So if you have any question, you can just ask me in the next class also. And both the derivations also you can make it. No, only one derivation, the von Mises one, because the Tresca is very simple. Sigma max minus sigma min by 2 equal to sigma f by 2. Okay, and if you have this one, only you have to define this one, because this first equation is perfect because this is based on the definition only, and then this equation is also no problem. Only the third, fourth, and fifth. Okay, third, fourth, and fifth. Only these three equations you have to derive. Okay, this is very easy. You can just put the tau 1 equal to sigma 1 minus sigma 2 by 2, tau 2 equal to sigma 2 minus sigma 3 by 2, and tau 3 equal to sigma 3 minus sigma 2 by 2. Okay, if you will put, then you will find these three equations step by step. Okay, maybe it will take time, but do not put sigma 1 minus sigma 2 square, sigma minus sigma to the value, then square. You have to put a minus b whole square. So a square plus b square minus 2. If you will put, then the equation is common. Okay. Okay, fine. So thank you, and you can go for the LMS, the new system what we have.
Thank you, sir.